Welcome to another video in the series about the TI-ARM-Clang compiler. This video explains how to dump the code coverage counters when the target system cannot write to a file. My name is George Mock and I'm your guide. C input-output operations like fopen and fwrite use a breakpoint, lots of memory, and so on. There are some systems that can't support all of that. So for such systems, how do you dump out the code coverage counters so they can be post-processed for the code coverage display? Well, it turns out the way to do that is to use a CCS script that copies from a range of system memory into a file on the host. The heart of this video is a demonstration, and this demonstration is based on an earlier video which is titled Code Coverage Basics. The steps that are taken in this demonstration that are the same as are in the Code Coverage Basics video are already done, or they're going to be done quickly. So if you get confused or you're not sure what's going on, the best thing to do is go watch the Code Coverage Basics video. The focus of this demonstration is on the steps specific to dumping the code coverage counters with a CCS script. All of this is based on an article currently online. There's the full URL. Don't worry, I don't expect you to type that in. That's just impractical. What works better is to go to a search on code coverage with TI-ARM-Clang compiler. And all the times that I've done that search with various different search engines, I get the correct link. I get this link right here in the first 3 results. The demonstration opens with CCS on the code coverage example project. It's on the collect build configuration. I want you to notice that the function LLVM profile write file is commented out. It's not being called. And that's the function that, ultimately uses fopen and fwrite, C input-output calls to write out the code coverage counters. And so we're going to do it another way in this demonstration. I want you to notice that the file default.profraw is not present in the collect build configuration directory right now. The first thing we do is to copy the script from the web page, which is I have open here. Conveniently enough, we're already on it. So the thing to do is select the text, and you can't see me do this next part, but I hit Control-C to copy all that text, and then I'm going to transfer Control to Notepad, just the most simple text editor I have, and Control-V, and here it is, and then I enter Control-S to save the file. I am conveniently located in the directory where I want it, which is code coverage example is the directory where the project is, and collect is the build configuration. That's where I want this file to be. We want to name this file dump coverage counters.js. This name can of course be anything you want, but in the example that I've created in the web article, that's the name I use, so I try to be consistent about that. So save. And the next thing we do is back in CCS, any moment now, there it is. We're ready to hit the debug button. Here we go. So this is going to load the program and get it ready to run. And now I'm going to press the play button to run the program. And this is the very same program that was in the Code Coverage Basics video. It's playing FizzBuzz. Let's watch it do that. This is simulating children playing FizzBuzz. That's described in the previous video. Okay, the program has completed running. And before we do anything else, okay, you don't want to end the debug session like by hitting this icon here to terminate the debug session. You don't want to do that. The next thing you want to do is bring up the scripting console. So View, here it is, Scripting Console, okay? And now we want to browse, we want to open up that JavaScript script we just saved. So press this icon here for open a file. Okay, we have to browse to where it is. Turns out this directory is it. Don't see it yet. What's going on? Well, we need to tell it to look for JavaScript files. Here it is. Okay, so select it, press open, and that causes the load.js file command to run. That's the file, that's the input to that command. Now we're ready to stop execution we need to stop the debug session. So let's go ahead and do that. And ta-da, here it is. This file was not here before. Default.prof_raw got created by all the processes that we just completed. The next step is to change to the Analyze Build configuration. There are a few different ways to do that, but I like to right-click on the project, select Build Configuration, set Active, change it to Analyze. So that's how I do it. So let's close up the collect build configuration and get a look at what's inside Analyze. There's a make file here. The changes related to this make file and everything, that's already all complete. That was all done in the previous video, if you want to know the details on that, but it's already done here. I want you to notice that the file index.html is not present. The directory coverage is not present. Those things are going to be created with the next step we run, and that step is to build the Analyze Build configuration. All right, which that's pretty quick in this case. Let's get a brief look at what happened. GMake is invoked with this stuff. Among the things that gets passed is the raw data file is the default.prof_raw. That's the file we just created using the JavaScript CCS scripting console command. Created that file, and then it's fed into the command prof data. Let's see, here it is right here. That's where it shows up, and so on. And these commands are all described in the previous video, so we don't need to go through this in any more detail. Notice that the file index.html and the directory coverage are now present. They were just created by these commands that we ran. So let's double click on index.html. And here's the coverage report. And click on this to see the information related specifically to the one source file in this little toy project, main.c. So this just shows that we dumped the code coverage counters and post-processed them, and now we're looking at the coverage information, all without ever using any of the C input-output functions such as fwrite and fopen. I'm going to close out this video by giving you a couple of references. The first one is to the homepage for TIARM-Clang. That's the URL, ti.com/TIARM-Clang. Here's where you can download the compiler and access the manual and more details like that. The second reference is to e2e.ti.com. This is where you go to ask any question about any TI product, including TIARM-Clang. If that question happens to be related to a compiler or one of the related tools, that question will be answered by me. Thank you for watching this video in the series about the TIARM-Clang compiler.